Hello and welcome back to Modern Infrastructure Wednesday, here at Pulumi TV. I'm your host, David Flanagan, although I go by the name Rockcode across the big bad internet. This week, we're taking a look at 3 cool new features that were released in just the last 6 weeks for Pulumi. Let's not waste any time and dive straight in. Alright, so let's take a look at the newest feature in Pulumi. Before we get started, we need a very simple Pulumi program. Simple. Okay, so the first feature we're going to look at just now is update plans. This was a long requested feature that gives people the confidence to run Pulumi in a pull request and continuous delivery process when the branch is merged. What you want is to ensure that a plan is generated at the pull request stage, saved as an artifact, and then when that pull request is approved and merged, that same plan can be executed, with the goal being that there are no changes that would cause anything to slip through the net. So let's see what this looks like with Pulumi. The first thing we need to do is export an environment variable to tell Pulumi that we're happy for our experimental feature to be played with. We turn on Pulumi_experimental equals true. Now, when I run a Pulumi preview, it shows us that it wants to create a random password. Assuming I'm happy with this, I can save my plan as preview plan. There's nothing particularly fancy about what is saved. It's just a JSON artifact that describes our plan. We can see that we have a new resource to be created. So now that we've saved our plan, let's modify our code. Let's come in and generate one more random password. This time for our admin user. Dun, dun, dun. Now this is a rather contrived example, but the use case and situation might be that when you approve something on a pull request and it's merged to your main branch, is that what you get may be slightly different. So let's see this in action by running Pulumi up, pass in -- plan, and pointing it to our plan file. What should happen is that Pulumi will detect that what is in our plan is now drifted from what is defined in our code, and no Pulumi updates will be actioned. Perfect. Pulumi has noticed the drift and told us that create is not allowed by the plan. No steps were expected for this resource. This is the new admin password that we added after saving the plan file. So let's assume we're happy with this. And we can save a new plan. And now we have that saved. We can run plan again. We can run Pulumi up and pass in our plan file. So now you can have guarantees that what happens on a pull request can be saved and executed safely upon merge. Okay, let's take a look at our next feature. This is another long requested feature for Pulumi, and that is top level async await with the Node.js runtime. It's a pretty common request from Pulumi users that they want to be able to use top level await in their Pulumi programs. And there are various use cases that make sense for this feature. It could be that you're trying to resolve the latest version of a Docker container image for continuous delivery. You need to send an asynchronous request to the registry to pull back a list of tags and parse them. Typically, that response would only be available within a then block. But with top level await, you can say that you wish to await the result and carry on your program without too much juggling. Let's take a look at a more contrived example. Let's assume that we want a super secret information. And we're going to use the fetch API to do so. So the first thing we do is import fetch from node.fetch. And now we can see that we want to hit http://bin.org anything message equals hello. Now, don't worry if you're not familiar with HTTP bin, but essentially anything that we pass to the anything endpoint will be returned in a response. And if we highlight the super secret information, we'll see that we get a promise of a response. Typically, we'd use a then, and we'd get data, and we could work with it here, like so. But working within these then blocks can be rather cumbersome. And recent versions of Node.js using ESM support top-level await. So let's delete all of that and instead say that we wish to await this result. We can then say data equals our super secret information.json. And if we look at this, it's also a promise. So we'll await that too. So let's just quickly console log and see what we get. We can run Pulumi up, and we'll see that we have now successfully fetched and printed out our very valuable information. We could now consume our args message as a Docker image tag, create a Kubernetes deployment, and we're plain sailing from here on in. But there's a few things to know about how this was set up. First, you need to come into your tsconfig.json, and you have to set target and module to ES next. The next thing you have to do is come to your package.json. You have to ensure that you have the latest version of Pulumi. Remember, if you're generating your Pulumi project from Pulumi new, those boilerplate templates may have a slightly older version. Always upgrade to the latest. And finally, you have to modify your Pulumi.yaml and add a Node.js runtime with options that tell it to use the TS Node ESM loader. And for this to work, there's one more thing that you need in your package.json, and that is TS Node. And that's it. You can now use top-level await in your Pulumi programs. And the last feature I want to show off today is the new command package. So let's see this in action. First thing we need to do is import star as command from the command package. From here, we can say that we want a local command equals new command dot local command. Now calling this who am I. From here, we can define commands to run when this resource is created and when this resource is deleted. So we're going to keep this nice and simple and run who am I on a create. On a delete, we're actually going to do echo bye-bye to a file called tempter bye-bye. We can then export the output and set that to our local command standard out. And now when I run Pulumi up, it'll detect our new local command, and when we run it, we get the who am I response available. We get the who am I response available in our stack. Finally, we can run Pulumi destroy. And we have bye-bye and the fail. Bye-bye. You can also use this for remote commands. We can say command.remote command and run the same thing. We specify the create, the delete, but now we can specify connection details. This can take a host, as well as a port, password, private key, and username. So whether you're using Pulumi or not to provision machines, generate SSH keys, you can provide everything that you need in a single program to handle all your local and remote command requirements. So that is my 3 favorite features of the last month from Pulumi. We have the ability to generate update plans, and that gives us guarantees that what we're merging from our branch and pull request process is what will actually be executed when merged with main. If you're not using a pull request process, you can still use these plans to make sure that there are no side effects in what you're trying to do. We also take a look at Node.js's top-level async await. This is going to allow for much cleaner code, a win-win for everyone. And lastly, local and remote commands. Local commands are great if you just need to be able to read something from a file or work out some context from the environment in which Pulumi is running. Remote commands are great when you're spinning up virtual machines and you want to interact with the user data in some way. Perhaps if you're spinning up a KDS cluster and you want to pull that kubeconfig back to allow deploying with a dynamic Kubernetes provider. And in fact, I wrote an article on this on pulumi.com/blog. So thanks for watching Modern Infrastructure Wednesday. I'll see you all in 2 weeks' time. Have a nice day.